Alright, lesson 2, fundamental compression, ignition, engine fuel system. Alright, let's see if we're recording. Testing, okay. Describe the fundamentals, compression, ignition, engine fuel system. Give information about the types, location, operation, spec, compression, ignition, engine fuel system components. Reference TM9 8000. Learning event 1. Describe the components, principles, operation, fuel injection system. Introduction. The function of the injection system is to the meter fuel and accurately deliver equal amounts of fuel to all cylinders at a pressure high enough to ensure atomization, control state rate, and duration inspection. Keep this threshold function in mind. You'll understand the operate various systems. Diesel engine, some of the gasoline engine, fuel injection instead of carburation. These several types of fuel injection systems are Army equipped multiple unit injection system, distributor injection, and pressure time systems. This shows figure 12 shows your multiple injection pump, the pump shaft, delivery spring, plunger, bypass port, control rack, delivery valve holder, delivery valve seat, plunger and barrel, inlet port, bypass groove, 2-segmented bypass helix, control sleeve, and then pump operation, emission, oil injection, and cutoff relief. Alright, your multiple unit injection pump. The multiple unit injection pump is each cylinder and has an individual injection pump which meter the fuel delivers a high pressure spray nozzle leads to the combustion chambers. The pumps are mounted in common housing operated with a common camshaft. Use the same control mechanism to ensure the equal amount of fuel each cylinder is proper time. Diesel fuel oil flow over the supply tank through the fuel filter, fuel supply pump. The fuel supply pump forces the fuel through additional filter over the injection pump. The injection pump forces a measured amount of fuel through the high pressure line of spray nozzle combustion chamber. Surplus fuel flows through the injection pump. The check valve of the common housing returns to the fuel supply tank. Alright, your multiple injector show the bleeder valve. The oil returns to the fuel pump. Fuel injection from charge from the injection pump, the fuel bypass passage, the spring. Fuel passes through the body of the location, needle valve, nozzle, tip, fuel. Nozzle. The proper engine performance fuel oil must be injected with the combustion phase in a definite spray form. They accomplish the spray nozzle hold the correct position with the cylinder headed by the nozzle holder. Alright, the fuel delivered in the injection pump flows through the high pressure line edge of the nozzle holder, passes through the edge of the filter, flows over the ducts and hold of the nozzle body, flows down in the pressure chamber, sprays the nozzle valve of the valve seat. The pressure fuel oil acts as a different area of the nozzle valve. At the moment the pressure fuel exceeds the exerted adjusting spring, nozzle valve is lifted off in the seat. Forces the orifice spray of the combustion chamber and of the engine. Nozzle valve returns the seat after injection pump as it ceases to deliver. The hydraulic opening pressure spray of the nozzle may vary between 1,000 and 4,000 psi depending on the engine combustion chamber requirements. Basically, wide differing shapes of the fuel spray, various combustion chamber design because of the wide range of engine power demands, variety of nozzles used with the multiple unit injection pump system. Essentially, there are two basic groups: pintle nozzle, hole nozzle. The pintle nozzles are generally used in engines with a pre-combustion tolerant turbulence and divided chambers. The hole nozzles are generally used for the open combustion chamber design. Nozzle holder holds spray nozzle in correct position. Engine cylinder provides a mean with the conducting fuel oil. Two nozzle conducts heat away from the nozzle. Figure 14 shows a unit injection system, which is not pictured. It's showed into starting from the top injector fowler. Rocker arm cover, adjusting screw, rack control lever, injection control tube, injector control rack, filter element, and copper tube, fuel injector, oil passes through the rocker arms, passes to the rocker arms, and then the cam fowler, camshaft, push spring rod, push rod, jam nut, clevisor, rocker arm, shaft, injector clamp, injector rocker arm, injector fowler, and back up the rocker arm cover. Alright, your unit injector systems consist of the injector fuel supply, pump, fuel oil, filter, fuel oil, manifold. The fuel is drawn with a supply tank with the primary filter, fuel supply, pump, the pump with the fuel with the source with the secondary filter, fuel intake manifold, which supply with the injector surplus. The fuel flow through the injector, return through the fuel inlet outlet manifold, the supply tank. Unit injectors combine the injection pump and the fuel flow with the nozzle, single housing, eliminating high pressure line. Units provide a complete independent injection system at each cylinder of the mounted in the cylinder head with the spray tip slightly below the top inside surface of the combustion chamber. The U-clamp bolted with the cylinder head fitting of the machine area reset to each side of the injector body, holding the injector in place with the water-cooled copper tube, which passes through the cylinder head of the tapered lower end of the injector seat of the copper tube, forming a tight seal with staying with the high pressure inside of the cylinder. Fuel oil supply within the injector is about 20 psi enters the body of the top of the filter cap. After pushing the fine grade filter element inlet passage, fuel oil follows the angular or ring shaped supply chamber between the bushing and the split deflector. The plunger operates up and down in bushings, and the bore, which is connected with the fuel supply with the angular chamber with the two funnel-shaped ports on one on each side at different heights. Your injector rocker arms. Injector rocker arms are actuated through pushrod engine camshaft and motion of the injector rocker arm transmitted with the plunger follower with a bear against the return spring. In addition, this reciprocating mounting motion, the plunger can be rotated with the operation during its axis of the gear, which is meshed with a control rock. Each injector control rack is connected with the joint lever, one on a common control tube, which is turned and linked to the governor and throttle. Alright, figure 15 shows the distribution injection system, camshaft, push rod, injector fuel inlet, rocker arm, injector, metering bob, distributor box, disc, fuel pressure, distributed index, fuel filter, fuel drive from meter, fuel pump, injector, distributor index, travel pressure pump, metering pump, electronic control, eccentric rocker arm cam, and then it goes from fuel tank to suction gear to suction bypass valve, pilot flow chamber, pressure gear, and then into the pump. Alright, distributor injection system. The system is automotive. The diesel engine class of low pressure system. Pumping meter with its distribution take place with low pressure. High pressure required with the injection built up with the injector with each of the cylinder. Suction gear pump with the lift of the fuel with the tank with the delivers it in flow chamber from which the second gear pump delivers a low pressure for the distributor. Fuel passes to the distributor tube metering pump of the distributor again with the injector when it's ejected with the cylinder. The distributor consists of the routing disc, rotating diff stations, and cover, which are connected to fuel lines running in the individual injectors. The stuffer covers the series of holes when properly indexed with the passage from the supply pump of the metering pump. The metering pump and plunger moves down with the suction stroke with the permits the barrel to fill with the oil. The disc continues with the rotate lines with the correct discharge hold of the cover just as metering plug rises and action main fuel pump can the force fuel into the proper injection line. Metering pump is closely fitted with the reciprocating pump motion with the job of the link of the plunger level the operated vertical lever control with the turn with the eccentric rocker level the returning running directly on the camshaft fuel pump main shaft. The position vertical lever of the eccentric over the rocker arm determine the travel of the plunger, consequently the travel of the meter plunger. As the meter plunger starts up with a controlled stroke with the pushing fuel with the injector that with passage form with the rotating distributor disc, the stroke of the meter plunger will determine the amount of fuel going each of the injector verified changing with the position vertical lever between the stop pins and the cam rocker lever. The injector consists of the forged body with the fitted plunger. The plunger is forced down against the spring when the rocker arm actuated push rod from the engine camshaft mount and the end of the body is a cup which contains the nozzle tip on. The inside stroke of the engine, the fuel pump, metering pump, the charge of the fuel, exact amount of the load speed with the engine to the cap. Cup pressure time system operates principle with the change of the pressure liquid flowing in the pipe change of the amount of liquid coming out the open end. Increases the pressure, increases the amount of liquid delivered. The pressure time system consists of fuel pump and with the governor supply dry lines and injector. Figure 16 shows the pressurized time gear pump. Alright, this shows that starting at 12 o'clock, manual knob, shutdown valve, gear pump, pulsation, damper, idle adjusting screw, maximum speed screw, idle spring, throttle shaft, governor plunger, governor weights, governor assist plunger, main shaft, tachometer, filter screen. Alright, your fuel pump. Fuel pump is made with three main points: a gear pump, pressure regulator, governor, and throttle. Gear pump drawn with the fuel of the supply tank, that delivers it under the pressure through the pump of the supply lines of individual injector. Pressure regulator, limited pressure fuel injector. Governor and throttle independently with pressure regulator, with the control of the fuel pressure regulator and to the regulator. The injector fuel circulates through the injector at all times except during the short period following the injection into the combustion chamber. The inlet connection flows down with the inlet pipe injector around the injector plunger between the body end of the cup, drain passage, drain connection manifold back to the supply tank. As the plunger comes up, the injector feed passes open fuel flow from the meeting orifice into the cup. At the same time, the flows past the cup out of the drain orifice. The amount of fuel enters the cap controlled by the fuel pressure against the metering orifice. The fuel pressure is controlled by the fuel pump. During the injection, the plunger comes down until the orifice is closed with the fuel, and the cup is injected into the cylinder. While the plunger is seated in the cup, all fuel flow from the injector is stopped. Alright, supply pumps. For injector pumps must be applied with the oil under pressure that have insufficient suction ability. The all injections require supply pump to transfer the fuel from the supply tank to the injector pump. Pumps are proposed to have positive suction, lift, but performance independent and normal variation, viscosity, pressure, temperature of the fuel. The pumps in use today are gear, plunger, and vane types. Your governors. Engine speed of the diesel engine is controlled by the amount of fuel injected. For the consequence, the injection system is displayed with a supply with the maximum amount of fuel will enable the engine to operate at fuel load with reach of the predetermined max speed RPM. However, the maximum fuel charge is supplied with the cylinder. When the engine is operating under partial load, no load, the engine overspeed will soon cause failure. All diesel engines require governors to prevent overspeeding with the engine until the little loads. Automotive diesel engines also demand control of the idling speed. Governors provide variable speed control beside with control minimum and maximum speed will hold the intermediate speed desired by the operator. Alright, learning event 2. Describe principal operation, compression, ignition system, engine, and air induction system. Air induction, naturally aspirated. The power developed with a naturally aspirated internal combustion engine depending on the density of the air injected into the engine. The natural aspirated engine air is drawn into the cylinder out of the intake stroke with the forcing action of the gas equal to the pressure difference for the atmosphere and the cylinder pressure. Cylinder pressure approaches the perfect vacuum with a zero pressure. Atmospheric pressure at 15 psi. Therefore, pressure forcing the air into the cylinder is 15 psi. The highest density that can be attained in atmospheric air density is not usually attained because of a certain loss of the internal combustion and leakage passage of the piston. Pressure drops across the restrictions and manifold leakage valve, and also heating of the air entry for the manifold, which tend to expand with the gas and decrease in density. All those losses work hard for an engine to breathe. Make it hard for the engine to breathe. This causes a slow response with accelerated depressed with reduced torque output before maximum power output. Engine speed is increased with the breathing. The engine becomes more difficult because each cylinder has a short time to fill itself with air-filled mixture. Alright, supercharging is an assistance given the air intake process with supplementary fans, blowers, compressors. Supercharging greatly increases the power amount of the engine, very little increase of the weight. The supercharger accomplishes with this is increasing the overall efficiency of the engine. Overall efficiency, internal combustion engine is affected by main factors. One factor, volumetric efficiency. Volumetric efficiency can be defined as the ratio of the weight of air actually drawn into the engine over the defined period type of the weight of the air would be drawn without loss of the present engine and leakage friction losses and heat transfer losses and so forth. The term volumetric efficiency is slightly misleading. The engine and the deficiency is the actual ratio of the weights, not volumes. However, the term is used in connection with the pump and compressor ratio of the volumes. This is term is applied with the engine efficiency also. Properties of the gas and their gases in relation to supercharging. A review of mass volume density applied with the gas is necessary to explain with the principle of supercharging. All matter of decline classified as solid or fluids. The fluids are in turn subdivided in liquid and gas. If the weight of the substance depends on the density solids and liquids may be considered to be essentially constant. This is not the case for the gases. For the density of the gas, proportional pressure applied. In other words, the pressure problem of the gases increase with the density will also increase with the two identical volumes of the gas under different pressure will not weigh the same. For example, at sea level 13 cubic feet, air weighs 1 pound, but at high altitudes, atmospheric pressure is lower. the same 13 cubic feet air weighs a good deal less. Mass, weight, and volume to the engineer has the different meaning of the weight, but in general the two may be considered the same. Volumes refer to the space occupied matter, with weight refers to the force of a certain volume of the matter exerted on the scale. Weight of any substance is directly proportional to the density and volume. Boyle's law: the volume of the gas gas can be reduced by applying pressure. This is known as the compression. Boyle's law states the volume of ideal gas is inversely proportional to the pressure upon it. Temperature is maintained constant. There is no ideal gas, but air conforms closely with the considered ideal. Air induction into the supercharger engine. Supercharger is essential for the pump whose function with the compressed air of the air-fuel mixture increase the density of the charge. The supercharger increases the power output in two ways: increase the density of air-fuel mixture delivered in the cylinders of the engine, increase maximum compression pressure. The compression ratio of the engine is constant with a greater pressure for the beginning of the compression stroke, with a greater will pressure for the end stroke. High compression increases the power output of the engine because of the burning temperature for the gas is higher, therefore more energy is released per stroke of the engine. Supercharged systems and pumps. Two types of drives. The two main driving supercharged pumps used in one system escaping exhaust gases use the drive of the turbine that is coupled to a supercharger impeller pump. This is called a turbo supercharger. Second method, mechanical drive powered by the gear train from the engine. Type of the pump's compressor. There are four basic types of compressors: diaphragm, reciprocating, rotary, and front central figural. Diaphragm reciprocating types are not used supercharging because of the limited amount of the air that can be handled. Rotary central figural compressors and non-reciprocating parts, large volumes of air can be handled per unit of time. For this reason, only rotating compressors, rotary, and central figural can be used for supercharging. This shows rotating compressor, the Roots supercharger in air. Alright, Roots type supercharger. Roots compressor blowers are designed especially for the efficiency diesel operation. It supplies fresh air needed for the combustion, so averaging two-cycle diesel engine, and in order to similar of the that of the gear type of the oil pump. The scavenging process, the charge of the air force for the cylinder of the blower through these sweeps all of the burned gas through the exhaust valve ports. The air also helps to cool the internal engine parts, particularly with the exhaust valve at the beginning of the compression stroke. When after scavenging, each cylinder will fill with fresh and clean air, efficient combustion. Alright, to enter the blower with the air cleaner picked up with the blower rotor loops and carried with the discharge of the side of the blower, continuous fresh air blow enters the air chamber. The cylinder blocks the sweeps over the intake of the cylinder liners. The angle ports of the cylinder liners creates a uniform swirl motion. Intake of the air is entered for the cylinders. The motion permits throughout the compression trunk facility scavenging and combustion. Central figure compressor. Show the central figure supercharger, the impeller, the air out and the air to output, the carburetor housing air flown off the rim of the impeller. Air enters the center. Centrifugal superchargers are turbochargers, non-positive displacement type compressors, high output capacity. Impellers are installed with the air inlet, usually made with the aluminum alloy forging, designed to withstand high centrifugal force of rotation. It is balanced accurately to reduce vibration. The radial vanes of the impeller catch the air, and the air centrifugally force through the radial passage formed by the vanes. Alright, compression will increase as the air is whirled and centered outward. More the air is pushed and rushes to fill the void. Enter the compressed air occupies previously progressively smaller volume of the travel through the hub. The velocity of the air decreases, and passing the hub into the perimeter decreases the velocity of the rise in pressure, called the diffuser compression. There are three types of three steps of compression: centrifugal superchargers. These are called centrifugal action, diverging counters at our outer perimeter and acting on the diffuser plate. Alright, learning event 3. Describe the procedure for the inspection, compression, ignition, and engine fuel systems. You may now have the difference construction operation between the fuel system, compression, ignition, spark ignition engines. There are a lot of differences mainly for the procedure for the performance of two systems. As well as the rule, maintaining the fuel system, compression, ignition engine for the engine returns even more knowledge, skills over the spark ignition systems. The mechanics are capable, well trained over the great demand, so it will be your advantage to put forth the best effort of the subject. It is true most of the major maintenance, compression, ignition, fuel systems will be done in fuel and electrical system repairs, but there are many things to be done with the organizational repair. For instance, you as a wheel vehicle mechanic working organizational level, the may be called upon to do any of the following: inspect, test, service, clean, tighten, make some of the adjustments, or even replace some components of the fuel air induction system. The work done by you will be detecting repairing troubles that while are small, but they have the chance of causing serious problems, and indeed this is the most important of all maintenance. Or inspect of the components. You probably do the work with the multi-fuel system on the diesel fuel system. The major part of the lessons will maintenance the air fuel system, 2.5 ton trucks M35A1 and A2, which are powered by multi-fuel engines. The following how should we go to the jump inspection air fuel system of these trucks. Start by inspecting fuel tank with a hose, rusty spots, and proper mounting. Tank with a rusty spot for the other parts of the rubbing against the tank. A leak will soon develop, and inspect with the filler cap to make sure that they seal with the filler neck that it was held with the retaining chain. The check with the condition filler neck. Fuel strains might make visual. Check with the fuel gauge sending unit with the fuel pump electrical connection. Check any of the damaged leaking fittings of the connection. Alright, trace the fuel feed and fuel return vent lines along the frame. Make sure that they are not broken, leaking, bent, crimped, or damaged in any way. Make sure that the lines are clipped to be securely to the frame so that they won't break with the vibration wears and holes and rubbing against the nearby parts. As you trace the fuel line will come in the primary fuel filter mounted with the frame bracket under the engine generator. Check the fuel filter closely with the screw of the mounting bolt leaks and damage. Open the drain valve at the bottom of the filler to watch the water. For any dirty water, always catch drain fuel into the container and dispose of it properly, as we will not cause a fire hazard. If any of the dirt whiz water is found in the primary filter, drain the secondary filter. If any found in the secondary filter, drain the final filter. But if secondary and final filters are mounted in the left rear of the engine, when a large amount of dirt and water is found in the filter, especially final filter, clean the primary filter, replace the secondary and final filter elements. Inspect the fuel injection pump, the operating linkage, connecting lines for the improper mounting, external damage leaks. Since the engine and lubricating oils and the injector pumps will have them to be look out for the leaks of the fuel leaks. Inspecting injector pump, also injection condition, protective dust caps, high pressure outlet, injection pump, hydraulic leak head. Extreme caution for checking the leaks working near the high pressure fuel line where the fuel is under enough pressure. Punctured skin could cause blood poisoning. Keep your hands away from suspected leaks while engine is running. Inspect high pressure lines and fuel injector nozzles, fuel return line damage, leaks, and proper mounting. Use a wrench to check the fuel injector nozzle. Make mounting bolts for the looseness. Loose bolts should be tightened to torque wrench. Move opposite engine of the compartment. Inspect the air induction system. Check the air intake rain hood for the excessive dirt. Check the air intake flexible tube for condition. Make sure that the flexible tube does not leak. Check the air cleaner mounting bolts for tightness. Alright, release the air cleaner body to body base mounting clamps. Remove the body from the base. Check the condition of the rubber seal of the mounting clamps to make sure that the base seal is airtight again for the cleaner body. Check the filter element, except for the dirt, evidence of water, hardening of the filler metal material for the external damage. Make sure that look over the entire fuel air intake system for anything that seems to be wrong. Look for broken parts, loose worn parts, leakings. Looking for anything that indicates that which may be trouble, if it may be causing trouble. This is another method of the learning system that may help to locate trouble. If the engine will run, starting for leaks around fuel lines connection, these known as the operational functional inspection. Remember, you have 5 senses that can help you locate the trouble. For example, smell and fuel, and seeing it leak, and hearing air whistling. It looks at the hole for the air cleaner hose is partly loose. Inspection malfunction vehicles. Once you have learned all that you can learn, look over the symptoms reported on the vehicle so that they may be in part defective, may cause trouble. Let's say the truck has lost power. Another system learned by the driver that it was using more fuel than normal. The two systems point out the engine is either getting too much fuel or not enough air. One of the more problem causes of either partially plugged air cleaner. However, do not start removing parts. Don't be hasty. Replace parts until all systems have been considered. Systems to show up the engine power, fuel consumption, exhaust system can also be caused by a fuel the air intake component. Poor troubleshooting may try to stop the engine using too much fuel from repairing and replacing parts fuel system. The main thing is to try to find out what actually causes the trouble. This is called the diagnostic system isolating the fault. Another trouble that you might find with the engine stop because of the no fuel being injected within the cylinders. This could be caused by the different conditions. Let's see how to proceed to locate this cause of the trouble. Remember, don't start removing parts, but guide visual inspection fuel system first. To include checking the fuel in the fuel tank, make sure the fuel lines are not cracked or broken. Examine linkage of the fuel injector pump. Accelerator linkage could be disconnected. End of the idle speed adjustment wrong. Cylinders would be out of fuel. Adjusting the linkage and that could cause the trouble. The fuel shut off control. Make sure that it's not improperly adjusted. Check to see if the shut-off control cable housing will slip rearward out of the clip of the fuel injector pump. The conditions cause the trouble and have the same effect pulling on the control of the cab. If you see anything wrong, check with the see if the fuel lines are open with the tank of the fuel injector pump. This will be done by first disconnecting the fuel line in the inlet side of the injector pump with a hydraulic head. Then turn the accessory switch, set it to fuel pump to the tank through the line. Make sure you catch the fuel in a suitable container. And above inspection, you find out the lines are not plugged in. The tank pumping is operating. The fuel does not flow with a disconnected line. The trouble has to be back toward the tank. If the fuel does flow, the trouble must be in the fuel injector pump, high pressure lines, and injector nozzles. If no fuel flows, there could be many reasons. The line fillers can be plugged. Intake pump might not be operating. If you listen close to the tank, you can hear the intake pump humming. When it is operating, the intake pump is operating. You can check its pressure, and the intake pump does not operate. Check the out electrical circuit in the pump. Alright, in the tank, intake pump is operating within shift with no fuel reach for the injector pump. The trouble is easily located with the intake pump running, loosening, fitting of the fuel line with only open bleeds on one at a time to see that the fuel will flow out. Start the final stage, engine second filter, work toward the tank. Let's say that the fuel leak when loosened, fitting on the tank side of the vehicle primary filter. However, no leak of the fitting on the engine side of the filter indicate that the trouble is in the filter and probably stopped and needs cleaning. If the fuel reach of the injector pump linkage is alright and problems must be in the injector pump with the injector nozzles lines, you are authorized to replace the high pressure lines. However, it is unlikely that they are plugged. The next step is to notify your support unit in the condition. Another problem you may find is fuel air intake and systems. Improper fuel air. Make sure clogged air cleaner with smoky exhaust, low engine power can also cause the truck to use much fuel air mixture combustion chamber. Make sure it's too rich, does not have enough air. Let's see what else can be an improper mixture of the air fuel. On some 2.5-ton multi-fuel engine turbochargers help supply engine cylinders. If the turbocharger is defective, the fuel air mixture becomes too rich, especially at higher engine speed. Defective turbocharger will greatly generally show the systems of the clogged air cleaner. This includes smoky exhaust, low power, use of too much fuel. You can check with the air cleaner for the first, then systems appear. If air cleaner element is not clogged, check the manifold heater gaskets. Leakage gaskets could be blown. Manifold heater below elbow could be loosened. Any leaks in the air will decrease the turbo supercharger output, causing the fuel air mixture to be rich. Manifold heater gaskets are not leaking. Air cleaner is not clogged as a fault in the turbo supercharger. You should notify the support maintenance unit because it is not authorized to test and remove or replace the supercharger. High fuel consumption problem that you should look into as soon as possible. The problem may not seem important, however, the driver and other personnel on board may be riding it with very unsafe. Or when a vehicle uses too much fuel, the first thing you need to look at is the leak of the driver's seat of the engine, or the develop the full power with the use of too much fuel. Good possibility that is what is wrong. Much of the fuel system on the right side of the vehicle, the hot exhaust system there is also. You can also see the danger. While looking at your leaks, make sure all fuel line fittings are tight, no leaks are found. Turn on the intake pump to recheck the leaks. Start the engine, check for leaks. Check the air intake system blockage, such as clogged air cleaner. Remember, the restricted air intake generally causes the blackest exhaust and low power. The engine will also use too much fuel with the injector pump out of the time. Improper adjusted generally with the engine out adjustment and also be low on power. It also seems to trouble to notify the support maintenance unit. Manifold flame heater aids in starting manifold engine when it's cold, and will have troubleshooting of the engine even with a manifold heater possible here. If they're not working properly, you can troubleshoot with the heater in the following manner. Inspect the engine air intake of the manifold and flame heater assembly. Make sure that they're connected properly with the fuel lines, wiring, ignition onto unit. Looking at all right, filled out with the system is fault, but it might be a fuel system ignition system. Alright, first make sure that there are no leaks in the intake manifold, flame heater switch is closed, no disconnecting high tension lead, spark plugs hold wire at a 1/4 inch of the metal part with the spark plug, have someone turn the intake manifold heater switch, and electrical part sparks continue to jump at the gap between the wire and the plug metal, the electrical system is alright. If no sparks jump, then check out the rest of the electrical circuit. If the electrical circuit is alright, check the fuel system up to the fuel pump, make sure the lines are not clogged when trouble lies with the fuel pump and nozzle, notify your support maintenance unit. You should now be able to see what makes a good troubleshooting procedure. Make sure you're making an inspection and remove any parts. Question vehicle operator possible to learn all the systems be able to give you. You may have to make an operational check to find the trouble, such as starting the engine and find the fuel leak. Always make a functional check after you have corrected the trouble to make sure that the vehicle is in operation condition. And then it goes into practice exercises, another blank page, and your answers. And then we are on to lesson 3, engine exhaust systems.